Every process on a Linux system has a number called a PID. PID1 is the first one, the ancestor of everything else running on your machine. But its role goes way beyond just being first. Let's look at what it actually does and why the kernel treats it differently than every other process. When you run a program on Linux, say a web browser or a text editor, the kernel creates a process to manage it. That process gets a unique ID number, it's PID. The kernel hands these numbers out sequentially. The very first process it creates during boot gets PID1. Every process after that is a child or grandchild or great-grandchild of that first one. It's a tree, and PID1 is the root. Here's what that tree looks like. PID1 sits at the top. It spawns services like SHD and Nginx. Those services might spawn their own children, a shell session, a worker process, but every single one of them traces back to PID1. If you run priesttree on a Linux machine, you'll see exactly this kind of structure with init or systemd at the root. PID1 has 4 critical jobs. First, it kicks off all the other processes when the machine boots, mounting file systems, starting network services, launching login prompts. Second, and this one surprises people, it's responsible for reaping orphan processes. When any process dies, it leaves behind a small record so its parent can collect the exit status. But if the parent is already dead, the child becomes an orphan. The kernel reparents it to PID1, and PID1 must call wait on it to clean it up. If PID1 doesn't do this, orphans pile up as zombie processes. They're dead but still eating a slot in the process table. Third, PID1 handles signals in a special way. Normal processes die when they receive sigterm or sigint. PID1 does not. The kernel exempts it. It will only respond to signals it has explicitly chosen to handle. This is a safety measure. Accidentally killing PID1 would be catastrophic. And fourth, PID1 manages the lifecycle of services, starting them in the right order, stopping them cleanly during shutdown. If PID1 crashes or exits, the kernel panics. The entire system halts. There's no recovery path. Without PID1, there's no process to manage anything, no one to reap orphans, no way to shut down cleanly. That's why the kernel goes out of its way to protect it. Signals like SQL from a non-root process won't touch it. This is also where containers get interesting. When you run a Docker container, whatever command you specify runs as PID1 inside that container. If your application doesn't handle signals properly, which many don't, you get weird behavior like containers that won't stop gracefully. That's why tools like Tiny exist. They act as a tiny, well-behaved PID1 that forwards signals and reaps zombies. PID1 is a role, not a specific program. For decades, the default was sysvinit, a relatively simple program that ran shell scripts in sequence to start services. Modern distros mostly use systemd, which is far more capable. It tracks dependencies between services, can restart failed ones, manages sockets, timers, and even user sessions. But systemd is also large and opinionated, which is why alternatives like OpenRC, Runit, and Six exist. They each handle the PID1 responsibilities differently, trading features for simplicity. On a typical Linux box, you can check which one you're running with cat proc. PID1 is doing more work than most people realize. Booting the system, cleaning up after dead processes, ignoring signals that would kill anything else, and managing every service on the machine. It's the one process the kernel won't let you kill for good reason. Thanks for watching. Check out the rest of Awesome Linux TV for more Linux videos like this. Bye-bye.